Hi, welcome to my channel pibyme Maths. This is WST02. Here we are solving January-February 2021 Statistics 2 paper. In the previous video, we have covered question number 1, 2 and 3. Let's look at question number 4 now. A continuous random variable has a PDF f of x is given where k and a are constants. Show that ka cube is 3. So we know when we integrate into the function from 0 to a in the given limit, you are going to get the area below the graph, which is 1. It should always be 1, right? So when you expand it, it's a square minus 2ax plus x square dx. Sorry, I need to put dx is 1. So it's going to be a square x minus 2x becomes x square becomes x cube over 3. 0 to a is 1. So when you sub in a, it's gonna be a cube minus a cube plus a cube over 3 is 1. These two can be cancelled, so ka cube over 3 is 1. Ka cube is equal to 3. That's what they want us to prove. Part B now. Use algebraic integration to show that a is equal to 6. We know e of x is 1.5, right? How do we find e of x? Integral x times f of x dx is 1.5, right? So integral 0 to a x times the function k times a minus x whole square dx is 1.5. So integrate, sub in the limits, get the value of a. I'm going to keep k outside. X times a square minus 2ax plus x square dx integral 0 to a is 1.5. So k times a square x, which is a square x square over 2 minus, you multiply these two, 2ax square, which is 2ax cube over 3 plus this becomes x cube x power 4 over 4. 0 to a is 1.5, right? When you sub in upper limit, it's gonna be a power 4 by 2, 2a power 4 by 3, a power 4 by 4 times k is 1.5. So when I simplify this, 1 over 2 minus 2 over 3 plus 1 over 4. 1 over 12. So ka power 4 over 12 is 1.5. Bring the 12 to the other side. 12 times 1.5 is 18. Ka power 4, right? You can write it as ka cube times a, right? We know ka cube from part 8 is equal to 3. So bring the 3 other side. You can write therefore a is equal to 18 over 3, 6. It's a 4-mark question. Part C now. Verify that median of x is this. Median is basically a value of x. When you sub in into the cumulative, you should get 0.5 because it's a 50th percentile. So we need capital F of x, right? Okay. I have copied the small f of x here. Let me find capital F of x by integrating this. So I'm gonna get, we know a is 6. We know ka cube is 3. We can get the value of k, right? K is basically 3 over 6 cube, 1 over 72. So 1 over 72 integral a minus x whole square, which is this after expanding, right? So 1 over 72 a square x minus ax square plus x cube over 3 plus c. Instead of writing a, the value of a is 6, so 36, 6. Now this value is also 6, right? We can sub in 6 here, not here. In this function you will get 1, or f of 0 is 0. That's the first condition, right? Since the lower limit is 0, so I'm going to find the value of c now. When you sub in 0, everything becomes 0. That gives us c is 0, therefore f of x is 1 over 72, 36x minus 6x square plus x cube over 3. Now we need to show that the median is 1.2. So when they say median is 1.2 to one decimal place, it can be 1.17, 1.18 or anything, right? We are not sure. It can be 1.21 also. So this is where we need to use the lower bound, upper bound to sub in into f of x. Okay, I put the function here. They want us to prove median Q2 is 1.2, right? Q2 is 1.2. Since it's a one decimal place, you put 105 and add and subtract. It's 1.15, 1.25. Let's find f of 1.15, f of 1.25. You should get the value smaller than 0.5 here, bigger than 0.5 here. So we can confidently say that median lies between these 2 points. So definitely median is 1.2. So let's sub in the values. 1 over 72 times 36 times 1.15 minus 6 times 1.15 square plus 1.15 cube over 3. 0.471888, less than this. Now I'm gonna sub in, change 1.15 to 1.25 now. 1.25 here, 1.25 here, 1.25 here, 0.503, etc. Therefore you can say median lies between 1.15 and 1.25. Therefore median is equal to 1.2 to 1 dp. That's all. A lot of working for a 3-mark question actually. Question number 5 now. A piece of wood AB is 3 meters long. Okay, this is AB, 3 meters long. 3 meter. The wood is cut at random point C. Let's say C is here. We don't know where the C is, doesn't matter. And the random variable W represents the length of the piece of wood AC. This is W. Find the probability that the length of the piece of wood AC is more than 1.8. So we need to note, we should write W follows uniform distribution of anything between 0 to 3, right? So if you draw the graph, it's gonna be 0 to 3. This is the graph, right? So when they say more than 1.8, we know this is 1 over b minus a, so 1 over 3 as per the continuous uniform distribution. Okay, so they want us to find the area more than 1.8, this area. So this length is 3 minus 1.8 times the breadth of the rectangle is 1 over 3. That's basically 1.2 divided by 3 is just 0.4, right? 0.4. It's just a 2-mark question. Now The two pieces of wood AC and AB from the form the two shortest sides of a right angle triangle. Okay, you see, we have a piece of wood AB. We cut the wood somewhere C. Now we fold it and we frame a right angle triangle now. Okay, let me try to draw a right angle triangle. Okay, let's say this is a right angle triangle. ACB, two shortest sides are AC and AB. So if this is W, this will definitely be 3 minus W because the total length is 3 meters, right? Now the random variable x represents the length of the longest side, the hypotenuse. Use the Pythagoras theorem. We know x square is equal to W square plus 3 minus W whole square, which is W square plus 9 minus 6W plus W square. We got the answer already. Another 2-mark question. Part C now. You may assume from random variables STU and for constants A and B, S is equal to AT plus BU. E of S can be written this way. Yeah, that's just a property. That's just one of the property of E of X. We know that already. Find E of X square. E of X square is E of, replace X square with this in terms of W. 2W square minus 6W plus 9. So you can write it as 2E of W square minus 6E of W plus E of 9 is just 9. Okay. For uniform distribution, we know E of W is A plus B over 2. That's a formula given in the data booklet. This is A, this is B. 0 and 3. So it's B plus A over 2 is 3 over 2. There is a formula for variance of W. It's B minus A whole square over 12, which is 9 over 12. 3 3s are 9, 4 3s are 2. You can find E of W square because variance of W is E of W square minus E of W whole square, right? So 3 over 4 is E of, you rearrange and find E of W square. Variance of W plus E of W whole square. So you're gonna get 3 over 4 plus 9 over 4, which is just 3. Now sub in everything here. 2 times E of W square, which is 3. 6 times E of W plus 9, which is 6 plus 9, 15 minus 9. You will get 6 is the answer. That's a 6-mark question actually. All these are your working. You need to show all these working. The last part, part D, it's a 4-mark question. P of x square is greater than 5. Again, replace x square in terms of W. 2W square minus 6W plus 9 is greater than 5. Take the inequality separately, or first simplify it one more time. 2W square minus 6W, bring the 5 here, plus 4 is greater than 0, which is same as P of W square minus 3W plus 2 is greater than 0, right? Which is a quadratic inequality. W plus 2 is greater than 0, so it's going to be W minus 2, W minus 1. Two critical values are 1 and 2. If you draw this one, because it's quadratic inequality, so when they say greater than 0, they are talking about these two pieces. So the solution is less than 1, greater than 2, right? So you can write this as P of W is less than 1 or W is greater than 2. So you need to find the probability of less than 1 plus greater than 2. Do not multiply. In probability, it's OR means union. You need to add them, right? So how do we find less than 1 and greater than 2? Now to find the probability, I'm gonna draw the diagram here. simple diagram quickly. It's 0 to 3, right? And this is 1 over 3. The first probability is less than 1. Less than 1. This area of this rectangle, which is 1 minus 0 times 1 over 3 plus. The second one is greater than 2, which is 3 minus 2 is the length at the bottom and the breadth is 1 over 3. So 1 over 3 plus 1 over 3, 2 over 3 is the answer. Question 6 now. The owner of a very large youth club has designed a new method for allocating people to teams. Before introducing the method, he decided to find out how the members of the youth club might react. Explain why the owner decided to take a random sample of the youth club members rather than ask all the youth club members. Taking a sample is a quickest way, quicker, cheaper, less time consuming. You can just write this. Suggest a suitable sampling frame. Sampling frame means a list actually containing the youth club members, that the name or if they have some roll number or something. So a list or the database of all the youth club members. What is a sampling unit? Sampling unit is every member actually. Every member is a sampling unit actually. Part D now. It's a whopping 7-mark question. The new method uses a bag containing large number of balls. Each ball is numbered as 20, 50, 70 and the probabilities are given P, Q, R. Okay. And then a youth club member takes a ball from the bag, record its number and replaces it in the bag. So the total count will be the same. He then takes the second ball from the bag, record its number. So he's taking 2 balls actually. The random variable M represents the mean of the 2 balls recorded, 2 numbers recorded. Okay. Given that P of M is equal to 20, mean is 20, probability of mean is 60 is this, Q is bigger than R. Show that the probability of mean is 50 is this. Probability of mean is 20 is 25 over 64. So how do you get mean 20? What are the 2 numbers you can take? 20, 20, right? For 20 it's probability P, so it should be PP. P square is this, right? So P is square root of this. Okay. And then here. What are the 2 combinations? 2 number combinations will give you mean 60. So he's taking 2 balls. It can be 50-70 or 70-50, right? So this probability is QR. This probability is RQ. So when you add them, 2QR is 1 over 16. QR is 1 over 32 when you divide by 2, right? And then we know when we add all the probabilities, P plus Q plus R is 1. So we know the value of P, bring it to the other side. Q plus R is 1 minus P. P is this. So 1 minus P is 3 over 8. So we are going to solve these 2 and find the value of Q and R now. So Q plus R is 3 over 8. So R is 3 over 8 minus Q, right? I'm going to take it as equation 1 and 2 first. So when I sub in R into equation 1, Q times 3 over 8 minus Q is 1 over 32. Which is 3 over 8 Q minus Q square is minus 1 over 32 is 0. Multiply throughout by 32. So 4 8s are 32. So 12Q minus 32Q square minus 1 is 0, right? Which is 32Q square minus 12Q plus 1 is 0. I'm going to solve this quadratic now. 32 minus 12, 1. 1 over 1 over 8, 1 over 4, 1 over 8. Q is 1 over 4, Q is 1 over 8. So we can write one more step here, 4Q minus 1 times 8Q minus 1. So we won't lose them all. We got two values of Q. Sub in here. When Q is 1 over 4, R is, wait, are they asking us to find PQR? No, they want us to prove that M is equal to 50 is 1 over 16. When do we get the mean 50? If you take both 50 and 50, right? That's both probability Q and Q. We don't need R actually, right? Oh, but there are two values of Q. Which one are we gonna use, right? We need to find out, right, which one is. So when you sub in Q is equal to 1 over 4, R is going to be 3 over 8 minus 1 over 4, which is 1 over 8. So Q is bigger here. Try 1 over 8. 1 over 8, 3 over 8 minus 1 over 8 is 2 over 8. R will be 1 over 4. So this is the condition that satisfies since Q is greater than R. That's what given in the question, right? Q is greater than R. So we need to use this Q. So when they say P of M is equal to 50, it's Q times Q. 1 over 4 times 1 over 4 is 1 over 16. They want us to prove it's 1 over 16, right? That's all. It's a 7-mark question.